Hi everyone. In this video, I am going to explain about the data operators in Verilog programming. So there are several data operators we are using in the Verilog programming. So I will explain about arithmetic data operators in this particular video. Remaining I will continue in the next video. So first, what do you mean by data operators? So data operators are used to manipulate various data types inside the Verilog programming. So manipulated data operators are used to manipulate types of data various types of data implemented to produce values in values on nets and registers. Very simple definitions. See, data operators, what do you mean by data operator? Suppose arithmetical operator is there. I am having two variables like a comma b. For example, I have two variables, a and b are two variables, two input variables. Okay, generally speaking, two input variables, and y is an output variable. Y is an output variable. I want to add a b and store it in the y. Then y is equal to a and b. That means a plus b. Y is equal to a plus b. So here a is an operator, a is an operand, b is an operand. The addition of these two is stored inside the operand y. It's an output variable. Okay, so what do you mean by here? See, data operator is used to manipulate various data types implemented to produce values on nets and register. What do you mean by net? What do you mean by register? Already we have discussed in the previous videos. So net is used for the combinational logic circuit variable declaration, and registers are used to declare the variables inside the always and initial blocks, nothing but a sequential logic circuits. Okay, so here y may be a net or it may be a register. So whatever the operation we are performing, that moves on to that particular net or register. So for this operation we are using some data operators. This is the internal data operator what we are using here. So data operator here, and all these are operands. Okay, so this is what y equal to a plus b. So there are several data operators we are having. I will explain all these. See, types of data operators. Types of data operators. First one, arithmetic. Second, bitwise. Third, reduction. Fourth, logical. Fifth, relational operators. Sixth, shift operators, shift right, shift left. Conditional operators. And last one, concatenation is nothing but joining to data. Okay, so now let us see what do you mean by arithmetical operators. Before that, a small table is there to describe what do you mean by this operations. Operator, and what are the arguments needed, and what is the result. What is the result? So arithmetic operator, first one. Arithmetic operator, pair of operands. We need pair of operands, and the result is word binary word. And bitwise operator, here also pair of operands and bitwise word. And next one, reduction operator, single operand. Single operand. Here we do not need two operands because it performs on single operand only. So here we have a result bit because we are reducing the size of the word. Logical. Logical, again we need pair of operands. Pair of operands. So result is a Boolean value. Boolean value is nothing but either 1 or 0. Boolean value. Because after logical operation we will be having either 1 or 0. Relational value. Relational operators. Relational operators also we have two uh, operands, so pair of operands, and the result is again Boolean value. So relation greater than, less than, equal to. If it is 2, again it gives 1, otherwise 0. Relational operators. And shift operand. Shift operand we have a single operand because shifting will be done for the same operand. So binary word, because we are not changing the size of the data. Suppose if it is a 32 bits of information, after that shifting will be having again the same data because new data will be shifted into that particular shifted data. And conditional, for that we need three operands, and we have an expression. Okay, so now let us see the first one, arithmetic operators. Arithmetic operators. So arithmetic operators, as I said, they work on pair of operands representing the numeric values expressed in binary, decimal, octal, and hexadecimal. It works on data expressed in binary, decimal, octal, or hexadecimal. Hexadecimal form. So whatever may be the form from 2 to 16 bits of information, it is used to add or subtract or multiply division. Output is always a numeric value. Output is always a numeric value. So arithmetical operators predefined on vectors like net and registers. So performed on vectors, nets and registers. The result is determined by modulo 2 power n arithmetic, and where n is the size of the vector. See here, arithmetic operations performed on vectors like nets, registers. The result determined by modulo 2 power n arithmetic, where n is the size of the vector. N is the size of the vector. Bit pattern is stored in register in unsigned form. In unsigned form. Bit pattern is stored in registers in unsigned form. Negative value is stored in 2's complement form, as I said. So negative form, suppose if any negative data is there, that negative value is stored in 2's complement form. 2's complement format, but interpreted as but interpreted as unsigned quantity when it is expressed in expression, when it is expressed as expression. Okay, so now what are the different types of arithmetical operators we have? Symbol, and what is the operation of that particular symbol. Okay, so plus, minus, star, division, and percentage. So here plus is for, you know very well, this is for addition. Plus is for simply addition, minus is for subtraction, and star is for multiplication, division only, and percentage is for modulus. Percentage is for modulus. Okay, how to use these operators in a program? Example program is there. So module arith 1. See here in Verilog, all the programs are started with module. Only module is there. No entity, no architecture. But where in Verilog, in VHDL, two parts of the program is there. One is entity part where the inputs and output ports are declared. Another one is architecture where the function is written. But whereas in the Verilog, everything will be written in the same place, that is called module. Okay, so module arith.1, here it is the name of the module. So register, and the size of a comma b is represented as 3 down 0, 3 down to 0, like this. See, register 3 down to 0 a comma b, that means a is of 4 bit and b is also 4 bit. And now I am taking wire 4 down to 0, which is of 5 bit, sum, difference 1, difference 2, multiplication result, and negative result, division 1 result, division 2 result, and then uh, that's it. Okay, so now first one, assign sum is equal to. So assign means the particular operation has to be performed and the result will be stored in the sum. So sum is equal to a plus b. Both are of same size. The result will be stored in the sum. See why we have taken the sizes are of different for output and as well as input is when you are adding two 4-bit numbers, the result may be greater than 4-bit. It may be a maximum of 5-bit. Because if the last MSB bits are ones, then 1 plus 1 is equal to 1 0, like that. Okay, that's why always better to consider 5 bits data as a result. So assign difference 1 is equal to a minus b, assign difference 2 is equal to b minus a. Okay, just for example, what happens if a is greater than b and b is greater than a, and assign mult is equal to a star b. Just this is the way to write a program. And assign division is equal to a divided by b, division 1, and assign division 2 is equal to a modulus b, and assign negative is equal to minus a. End module, no space, end module and no semicolon, nothing. Okay, end module. This is the way of writing a program, and these are the examples of your arithmetical operations. Okay, remaining operators we will see in the next video. Thank you.